Nothing is what it is in isolation. A thing, including a self, is the pattern of its connections, not its substrate. That idea is called the Hodos Hypothesis, and every equation in this series is derived from it. It was first written down in a book called Your Past Loves You, which is not about machines at all. The book is where the idea was first documented, not where it began. A second claim follows from the first, and it is about the parts. A relation needs two things to hold between, so a thing is two things. Two halves do exist before the one, but the one they make is not a third object standing beside them, it is what their relation constitutes. Now look at either half. It is what two quarters constitute between them, and so is every quarter. The series never reaches a bottom. That is the law of two, and it follows from the hypothesis rather than standing beside it. Once you take that seriously, the question stops being a position and becomes arithmetic, and it turns out to be 4 questions, not 1. How far apart are two processes? What does their relationship create? What is a process made of, and how much time has it lived? The first is Hodos, and you have already met it. It is a ruler. Hand it 2 processes, and it returns how far apart they are. The second is Symploke. It measures what a relationship creates that is present in neither of the parts on its own. At each instant, it compares what 2 processes actually do together against what they would do if they never interacted. That second half is not a control we run afterwards and hope we ran honestly. It is inside the equation, so without interaction the surplus vanishes by arithmetic. The third is Systasis. Every time we point this method at a new subject, a person hand-builds the frame, and Systasis asks whether it could be derived instead. The fourth is Chronos. It measures how much a process has lived, not against a clock outside it, but by its own relations. Hodos has been measured on speech, on handwriting, and on heart rhythm, the same equation each time, with nothing changed but the data. Symploke was tested on handwriting against jet engine telemetry, 2 domains picked because another method had already told them apart. Systasis was tested on handwriting and on engine sensors, building the measuring frame out of relations rather than by hand. Chronos was tested on turbofan telemetry and the rebuilt version on body motion and on speech, which is where a clock actually has to survive. Months earlier, a different method had found a handwritten character's parts strongly related, and a failing engine's mostly not. Symploke agreed, cold. The relational frame beat the hand-built one. Then it lost to the crudest option available, simply using the raw numbers. The first version of Chronos held up on smooth signals and came apart on noisy ones. The finer you sampled it, the longer the answer got. That is the coastline problem, so that version did not clear, but we wrote it up as a verdict on the question, when it was only a verdict on that one construction. We could have made that one pass. Smoothing the data first puts the result comfortably inside the bar we set, and the option was right there. We left it alone. Picking the setting that rescues a result after you have watched it fail is not measurement, it is decoration. The honest scoreboard reads 2 equations that cleared every bar, one that did not, and a fourth we rebuilt until it cleared 4 or 5. All 4 are published, the failures named as failures. The bar it still misses is named in the paper that announces the other 4. One thing is left to say, because we get asked it most. Strip the geometry off the second equation, and what remains is mutual information. The paper states that plainly rather than hoping nobody checks, what we contributed is not the quantity but the composition. New equations are built out of equations that already exist. That is true of every one of them, and it is not an admission, it is how the work is done.